Okay, let's just dive right in. We are living through this really strange, very tense moment in the tech world. It feels like two completely different realities are just colliding.
Oh, yeah.
On one side, you have the whole enterprise reality, which is all about security, stability, keeping the lights on.
The don't touch it if it's working crowd. Slow and steady.
Exactly. And then on the other side, you've got the generative AI reality, which is just it's moving at warp speed, it's breaking things constantly, and honestly, it feels a little bit like the Wild West.
It creates this massive amount of friction. I mean, it's the classic irresistible force meeting the immovable object, right? Everyone wants the magic of AI,
Oh, for sure.
but nobody wants the chaos that, usually comes with it.
Right. And that is the friction point. That's what we are looking at today. We're doing a deep dive into practical RHEL AI. And before you tune out thinking this is just some software update, stick with us because the sources we're looking at today describe this not just as an OS, but as a bridge, a way to solve what they're calling the enterprise AI paradox.
And that paradox is the perfect place to start. Because if you look at the landscape, companies are desperate to innovate. They see the power of large language models, LLMs.
They know they need it.
They know they need it,
Yeah.
but they are absolutely terrified of the implementation.
Well, sure. I mean, if you break the bank on cloud costs, or even worse, leak your proprietary data to some public model, the innovation doesn't matter much.
No, you're out of a job.
You're out of a job. So our mission today is pretty specific. We want to understand how an organization can go from, say, fine-tuning a model on a Friday to actually shipping it to production on Monday without, setting the whole data center on fire.
That is the goal.
Hmm.
And we've got a stack of technical guides, architecture slides, and workflow diagrams here that lay out exactly how Red Hat is trying to do this. It's all about moving from that day one excitement to day two operations.
Let's start with the pain, because the source is laid out so clearly. Slide 1 paints this really vivid picture of the current chaos. They call it the friction.
Right.
And they list 3 specific things that are just driving IT directors crazy. The first one is tool chain breakage.
Yes.
Huh.
This is that classic disconnect between dev and production. You have data scientists in their Jupyter notebooks, on their laptops.
Right, on their MacBooks.
Exactly. Using the latest bleeding-edge Python libraries. They build something amazing. It works perfectly. And then they throw it over the wall to the ops team, and
it just explodes.
it creates a total dependency nightmare. The ops team looks at it and says, we can't run this. It's not compliant. The drivers don't match. These libraries are insecure.
It worked on my machine problem.
Yeah, but at an enterprise scale.
Yeah. Okay, the second point is my favorite just because of the imagery. They talk about infrastructure chaos. The quote in the source is that GPU clusters are currently behaving like cats on a hot tin roof.
That is a fantastic image.
Yeah.
It really captures the unpredictability. You have these incredibly expensive resources, H100 or A100 GPUs that cost as much as a luxury car.
Easily.
And just managing them, keeping them utilized without crashing the whole system is a nightmare. If you don't have the right drivers, they just sit there idle, burning money.
Or they overheat.
Or they overheat and crash the node.
Yeah. And that leads to the third friction point, governance lag.
This is the big one for the boardroom. I mean, usually compliance teams only show up after the models have already gone off the rails.
That's always reactive.
Always. The innovation happens so fast, the rulebook just can't keep up. So you end up with shadow AI people using tools they shouldn't. Data going places it shouldn't.
All because the approved path is just too slow.
Exactly.
So enter the hero of our story, RHEL AI. The source describes the solution to this paradox with a phrase I really like: discipline velocity.
Discipline velocity. I like that too. It implies speed, but
Yeah.
Not reckless speed. The whole goal here, according to the docs, is to create a reproducible recipe for AI services.
Something an auditor can look at.
A system that auditors, SREs, and even the CFOs will actually sign off on.
Which is a tall order. Usually you get to pick 2, right? Fast, cheap, or safe. They're claiming you can get the safety and the speed.
So let's look under the hood. What is RHEL AI? Slide 3 breaks down this stack.
It's helpful to think of it as a complete foundation model platform. It's not just Linux, it's a whole bundle. At the very bottom, you've got the hardware abstraction.
The drivers.
The drivers, exactly. And what's really important, our source to highlight this, is that it includes optimized drivers for both NVIDIA using CU and AMD using ROCm.
Why is that detail so important? I feel like everyone just uses NVIDIA.
Well, 90% of the market does, and that creates a massive supply chain bottleneck. You just can't get the chips.
By officially supporting AMD alongside NVIDIA, RHEL AI gives enterprises a choice. It means if the supply chain for one vendor dries up, you have an alternative. You are not locked in.
That's huge for procurement. Okay, so on top of the drivers, you have the OS layer, which is Red Hat Enterprise Linux 9.
RHEL 9, and this is what provides the stability. It brings in things like Linux for access control and FIPS 142 compliance.
Okay, so FIPS. Just break that down for us real quick.
FIPS compliance is basically the gold standard for this is secure enough for sensitive data. If you work in government, healthcare, or finance, you generally cannot deploy software that isn't FIPS compliant.
So it's a non-starter without it.
It's a non-starter. So having that baked into the OS layer solves a massive headache for the security team right off the bat.
Okay, so we have hardware drivers, a secure OS. What's the actual AI part of this?
That's the top two layers. First, there's the toolkit, which is called InstructLab. We're going to spend a lot of time on that later because it's really the secret sauce. And then finally, the models themselves. RHEL AI comes with the Granite models, which are open source models from IBM.
So it's a full stack. You don't have to piece it all together. The source mentions 3 key attributes for this stack: security, reproducibility, and portability.
And portability is the one that really stands out to me. They talk about bootable container images. This is a step beyond just a standard Docker container.
How so?
It means you can package your entire AI application, the OS, the drivers, the model, the libraries, everything, into a single image that can boot up anywhere.
Anywhere. Like literally anywhere.
Anywhere. You can boot it on a server, under your desk, in the cloud, or at the edge, like inside a factory. And because it's the exact same image, it ties back to solving that toolchain breakage problem.
No more, it works on my machine.
Exactly. If the container runs on your laptop, it's guaranteed to run the same way in the data center.
Okay, let's zoom out a bit. We know what it is. But where does this fit in the grand scheme of AI? Slide 4 shows this spectrum of enterprise intelligence.
It's really a maturity timeline. It traces the evolution of what we want computers to do. We started with predictive AI.
That's the stuff we've had for a while, right? Spam filters, fraud detection.
Exactly. The goal there was perception. Is this email spam? Yes or no? It takes structured data and makes a classification. Very useful, but limited.
Then we moved into the current hype cycle, generative AI.
Right. And the goal here is content generation. Write me an email, suggest some code. This is where RHEL AI is laser focused right now. It's all about enabling LLMs for these tasks.
But the chart goes one step further. It talks about agentic AI. That sounds a little like science fiction.
It's the near future. The goal of agentic AI is autonomy, decision execution. So instead of just suggesting code, the AI might identify a bug, write the patch, test it, and deploy it.
A self-healing system.
A self-healing system.
That is both exciting and a little terrifying.
It is risky, for sure. But what's fascinating here is how RHEL AI positions itself. It says it converges these domains. It lets you run the LLMs for the generative part, but it integrates with tools like Ansible,
The automation tool.
the huge automation tool, to start building those agentic workflows, but with guardrails.
So it's building the tracks for the train that's coming next. Now, I want to clarify something. We're talking about RHEL AI, but Red Hat also has OpenShift AI. Are they the same thing?
No, and slide 5 makes a very sharp distinction here. It's all about dev versus prod. Think of RHEL AI as the entry point.
So that's for the developer on their laptop.
Yes. The target audience is developers, single-node setups, edge cases. It's for the inner loop of development, local, fine-tuning, experimenting.
And OpenShift AI.
That's for production scale. Once you've built your model in RHEL AI and you're ready to serve it to 10,000 users, you move it to OpenShift AI. That's where you get Kubernetes scaling and full CI/CD pipelines.
Got it. So start with RHEL AI for flexibility.
And scale with OpenShift AI for reliability.
It's a baton pass.
Precisely. RHEL AI is the workbench. OpenShift AI is the factory floor.
Before we get into the really deep nitty-gritty stuff, I want to ground this in reality. Slide 6 lists some real-world applications, and these are not small players.
No, these are heavy hitters. Take Boston Children's Hospital. They're using this tech in healthcare for radiology workflow support.
That sounds incredibly high stakes. What does it actually do?
Well, they aren't replacing radiologists. They're using generative models to support the workflow. The AI can analyze imaging data, flag potential anomalies, maybe summarize patient history for the doctor.
So it's an assistant.
It's an assistant that improves diagnostic accuracy and speeds things up, which in a hospital, literally saves lives.
Then there's Dennis Bank in finance using it for fraud prevention.
And speed is everything there. The source notes they're analyzing transactions at millisecond speed. When you swipe your card, the bank has a tiny fraction of a second to decide if it's you or a thief.
You can't have lag.
You can't do that if your infrastructure is lagging. You need that optimized stack we talked about.
And the third one is Hitachi in manufacturing.
Predictive maintenance. They analyze sensor data from machines, vibrations, temperatures. The AI predicts when a piece of equipment is going to fail before it fails.
Which saves millions in downtime. Okay, so this is real. Let's say I'm sold. I want to spin this up. What do I actually need?
Slide 7 gives us the pre-flight checklist for running on bare metal, a physical server. And it's actually surprisingly accessible for a dev environment.
Really? What are we talking?
Storage-wise, they recommend at least 60 gigs total. RAM, 16 gigs minimum.
16 gigs. That seems low.
It is for training a massive model from scratch, but for that inner loop development, for fine-tuning a smaller model, 16 gigs gets you in the door. It means you can run this on a high-end workstation.
You don't need a supercomputer to start.
Exactly. But if you want to go fast, you need GPUs.
Yeah.
And they list the big ones, NVIDIA A100, H100. But again, they explicitly list the AMD MI300X. That flexibility is just key.
But what if I don't have a server rack? What about the cloud?
All right, slide 8 covers that. RHEL AI runs on all the majors: AWS, Azure, Google Cloud, IBM Cloud. And the source even lists specific instance types. On AWS, they point you to the P5.48 Airs Large.
That just sounds expensive.
It is a beast. It's packed with H100 GPUs. But the point is, the software is validated on these. You can swipe a credit card and have a supercomputer class environment running in minutes.
And because it's portable, you can just use it for a few hours.
Exactly. Train your model, shut it down, and move the model back to your local server.
Okay, here's where it gets really, really interesting for me. We have the hardware, we have the OS, but how do we actually make the AI smart? This brings us to InstructLab.
This is, in my opinion, the most disruptive part of the whole platform. InstructLab is designed to democratize LLM tuning.
Democratize is a word that gets thrown around a lot. What does it mean here?
It means breaking the bottleneck of expertise. Right now, if you want to teach an LLM about your company's internal policies, you usually have to be a Python wizard. You have to understand data formatting, tokenization.
It's a whole science project.
It's a science project. InstructLab uses something called taxonomy-driven development. It completely changes the interface for contribution.
Okay, walk me through that workflow.
It's a cycle. First, a developer or, and this is key, a subject matter expert.
A doctor, a lawyer, a mechanic.
Exactly. They chat with the model and find a gap. Hey, this model doesn't understand our new travel policy.
So they find something it doesn't know. What happens next? Do they write code?
No. And that's the innovation. They contribute skills using simple YAML files. YAML is just a text format. It's super easy to read. They basically write out Q&A pairs.
Like, question, what is the per diem for travel to Chicago?
Answer, the per diem is $50. That's it. That text file goes into a review process, just like software code. It gets checked into a Git repository.
Okay.
Once it's approved, the system takes over. This is the generation phase. The system uses those few human examples to generate thousands of synthetic examples. And finally, a new trained model is released.
So it decouples the knowledge from the infrastructure. The expert provides the knowledge, the system does the heavy lifting of training.
Exactly. It turns training an AI from this arcane science experiment into a standard business process. It makes it boring in the best possible way.
You mentioned it generates synthetic data. That seems crucial. Slide 10 gets into the methodology behind this, which they call knowledge distillation.
It's a great analogy. The concept is you're transferring knowledge from a huge, expensive model to a smaller, faster one.
So you have a teacher and a student.
Exactly. You have the teacher model. The source uses Mixtral 8x7b as an example. It's large, complex, has incredible reasoning, but it's slow and expensive to run.
And the student.
The student model. In this case, maybe the Granite 7b model. Much smaller, faster, enterprise-ready, but maybe not as creative out of the box.
So how does the teaching happen?
The teacher model takes those simple YAML files the human wrote, and it generates synthetic data. You give it 5 examples, and the teacher can generate 5,000 variations. It creates a massive synthetic corpus.
And the student trains on that.
The student trains on that corpus. So the student learns to reason like the teacher without needing the teacher's massive compute power to run in production.
That is incredibly clever. It's like hiring a Nobel laureate to write a textbook, so your undergrads can learn the material without needing the professor in every single class.
That's a perfect way to put it. You get the reasoning of the big model with the cost profile of the small one.
Let's look at the mechanics of this taxonomy. Slides 11 and 12 break down the file structure. What am I actually editing?
Right. So the taxonomy is just a directory structure. It's divided into two main categories, skills and knowledge.
What's the difference?
Skills are do this tasks. Things like rhyming, reasoning, maybe formatting data. Take this paragraph and rewrite it as a JSON object. That's a skill.
And knowledge.
Knowledge is know this facts, corporate history, product specs, legal codes. The company was founded in 1999. That's knowledge.
And inside those folders, what are the files?
You have the qi.yaml file. This is the recipe with your seed examples. And critically, there's an attribution.txt file.
Why is that critical? Feels like something I'd ignore.
You can't ignore it in the enterprise. It's for transparency and licensing. If you're pulling knowledge from a textbook or a website, you need to cite it. In the corporate world, I don't know where this data came from is a lawsuit waiting to happen.
Ah, so it forces good data hygiene.
Exactly. It forces you to document the source.
Okay, slide 13 brings up a problem I hadn't even thought about. Data starvation.
It's a huge issue. High-quality, human-labeled data is incredibly scarce and expensive. You can't just hire enough people to write millions of high-quality examples.
So how does InstructLab fix this? The visual on this slide is really helpful.
It's the synthetic data generation, or SDG. And the visual in the source is a prism.
I see it. You have a single seed. That's the human example going into the prism.
And the teacher model acts as that prism. Takes that one seed of light and it blasts out a whole synthetic corpus, a whole spectrum of thousands of training examples.
It multiplies human effort.
By orders of magnitude. One good example from a human becomes 1,000 training points for the AI. That's how you get the velocity.
Okay, almost at the end of the workflow. We've written our YAML, we've generated the data. How do we actually run it? Slide 14 shows the command center.
And this is where the Linux part of Red Hat really shines. It's all done through a simple command line tool called ilab.
Is it complicated?
It looks surprisingly simple. It feels like standard admin work. ilab config init to start a project.
Okay.
ilab data generate to run that prism process. Then ilab model train to kick off the GPU accelerated training.
And then to actually use it.
ilab model serve to host it locally as an API, or you can just do ilab model chat to talk to it right in your terminal and test it out.
It makes this whole complex process feel like managing a web server.
And that's the whole point. It stops being AI magic and it starts being system administration. It becomes manageable. Boring.
Which brings us to the conclusion. Slide 15 has this final readiness checklist.
It recaps the big wins. 1, secure foundation. You've got RHEL 9, Selenics, FIPS. The security team is happy.
Check.
2, democratize tuning. Your SMEs contribute with YAML, not code. The domain experts are happy.
Yeah.
And 3, hybrid scale. You can deploy this on bare metal, AWS, Azure, wherever. The architects are happy.
And there's a quote here from the source that just sums up the philosophy so well. Make enterprise AI boring in the best possible way.
I love that sentiment. When a technology becomes boring, that's when it becomes truly useful. We don't talk about how electricity works, we just flip a switch.
We just stream video.
Right. Red Hat wants to get AI to that point where you focus on delivering features, not on fighting the infrastructure.
So for you listening, the immediate actions are pretty clear. You can download the RHEL AI ISO, run ilab config in it, and try building your first qni.yaml skill.
It's accessible now. You can actually go and do this.
And that leads me to my final thought. We talk about how InstructLab lets anyone put knowledge into a model just by writing a simple text file.
Right.
So here's the question. If the barrier to training a powerful AI model is now just a YAML file and a few good examples, what knowledge is locked in your head right now that should be in your company's AI? What are those unwritten rules, the specific expertise, or the specialized history that you know that the AI doesn't? Because for the first time, maybe the bottleneck isn't the technology, it's just you writing it down.
That is a very powerful question.
Yeah.
The value has really shifted from the code to the curation of our own knowledge.
Thanks for diving in with us.
A pleasure, as always.
Catch you on the next deep dive.